Hello friends, welcome to Learner's Planet. Friends, this is our third session for percentage. Friends, I'm sure you might have revised the previous two sessions before attending this particular session. In this session, we'll be taking the application part of percentages. Okay, so let's begin this session. Friends, in this session, we'll be taking applications of percentage in our day-to-day life. Okay, and definitely these problems are, even these cases are very useful as far as the competitive exams are concerned. Okay, we'll be taking the cases of even mensurations, that is volume, surface area, and we'll be taking the cases of even commodities, when what happens when the price of any commodity is increased by certain percentage, then what would happen to the consumptions and all that. Okay, so the very basic thing over here is, do not try to memorize so many formulae. You just work on your logics. Okay, that means along if you are working along with me, or if you are solving the problems with me, definitely logical skills will be enhanced. Okay, so let's take this very basic problem here. The price of an item is increased by 20%, then decreased by 20%. What is the final price as compared to the original price? Friends, let's do some mental exercise. Price of an item is increased by 20%. That means price of item is getting 120% of its original price. Now what 120% is? It is actually 6 by 5. Okay, so first of all, the price is getting 6 by 5. Then it is decreasing by 20%. That means what 20% decrement is? It's actually getting 80%. Okay, so first of all, it is getting up by 20%, then it is getting down by 20%. That means first of all, it is being 120%, then it is being 80%. Okay, now this is the concept. Okay, now how would we apply that? It's very simple. First of all, let's take the basic value as 100. The price is increased by 20%. That means we are getting 120. Then this 120 is being decreased by 20%. So what is 20% of 120? That is 24. That means we are getting down by 24. So 120 minus 24 will be getting 96. Okay, so it's 20% increase, then it is 20% decrease. So finally we are reaching 4% decrease. Okay, that is 4% less. Generally what students do, they just see first of all the price is increasing by 20% and then decreasing by 20%. That means there is no impact. But friends, we must be very clear that in both the cases the base is different. Okay, in the first case, the base is 100 on which the price is increasing by 20%. In the second case, the base is 120 on which the prices are decreased by 20%. Okay, so you should be very careful about it. Okay, actually the problem is very simple. First of all, you are increasing it by 20%, which you can do manually or mentally. Okay, then you are reducing it by 20%. Okay. So in all, we are getting a 4% decrement from the initial value. I hope you are clear. Apart from that, we can apply one logic also over here. If the prices of item is increased by 20%, that means it's getting 6 by 5, then it is decreased by 20%. That means two operations are being done consecutively. That means first of all we are making it 6 by 5, then it's 4 by 5. So we are actually getting 24 by 25 of the original value. That means we are losing 1/25 of the original value, which is 4. Okay, and if original value is 4, that means if original value is 100 and we are losing 4 part of it, that means we are losing 4% of it. Okay, apart from that, you can also remember the concept. If the changes in prices are same percentage, that means it is increased by say x% and decreased by x%, then in all it is x square by 100% decrement. Okay, doesn't matter the order of increment and decrement. First of all you may increase then decrease, or first of all you may decrease and then increase. Okay, in both the cases, finally we'll be losing x square by 100%. Okay, so I have discussed 3 to 4 concepts to solve this particular problem, and we'll be using the same concepts to solve more problems. Okay. Now let's say this question. Out of a number of electronic items, a person purchases 60% color TVs. 5% of these were found to be defective. The percentage of defective TVs in all is what? Okay. Suppose he's purchasing 100 items. Out of that, 60 are TVs. That is color TVs. Out of the 60, 5% are of these are defective. So what's 5% of 60? That is 3. Okay, so it's 3%. Now let's see this question. On decreasing the price of fans by 30%, the sales is increased by 20%. What is the effect on money receipt of the trader? Friends, let's do this problem by taking a base value. Okay, now what's the funda behind this is price per unit into number of units is equal to revenue. Yes. Now suppose initially both of them are 10. Okay, you can assume it to be 10. So initial revenue is 100. Okay. Now the price is decreasing by 30%. That means the price is now 7. Okay. And number of units are increasing by 20%. That means number of units are now 12. So what is the revenue generated? That is 84. Okay. Initially it was 100, now it is 84. So what is the decrease? That is 16. And since the base was 100, so it is directly 16%. Okay. Even you can do this calculation mentally. I hope you are clear. So 16% decrease. Friends, let's now discuss some area percentage related problems. While discussing this topic, we must be clear about the basic formula of mensuration, that is areas, circumference, perimeters, all that. Okay, volume. Okay, if the case of 3D figures. Okay, so first of all, we have to identify the number of variables in each for each quantity. In this case, suppose it's an area. Now, area of a rectangle, there must be 2 variables. Okay, that is length and breadth. Okay, suppose I take the example of this is a rectangle, and same will be the case with square. Okay, suppose I take the example of circle, then there will be single variable, that is radius. Okay, so radius r. Now if I talk about area of circle, that will be pi r square. That means area of circle is proportional to square of radius. And if I talk about circumference, then it will be 2 pi r. Okay, so for every quantity there is a relation. Here the relation is between area, length and breadth. Here the relationship between area and radius. Here the relationship between circumference and radius. Or suppose I take the example of a cylinder. The volume of cylinder is pi r square h. That means there are 2 variables, that is the radius of the cylinder and height of the cylinder. Okay, so similarly various examples or various quantities are there in the mensuration topic. Okay, in all the cases, first of all, that means the very first step is to identify the formula and its variables. Okay, let's take one example. First of all, let's take the very simple case of area of a rectangle. Now what is area of a rectangle? Area A is equal to length into breadth. Friends, initially we must assume the variables to be 10. Okay, doesn't matter it is a rectangle and length and breadth must be different. Okay, since in the calculation of percentage change, it doesn't make any difference. So the length is 10 and breadth is 10. then the area will be 100. Okay. Now if there is any change in length and breadth, we'll be getting the change in area immediately as the base is 100 only. So we'll be directly getting the percentage change. Okay. Now suppose length and breadth, both of them are increasing by 10%. So what will be the new length? It's 11. And what will be the new breadth? That is 11. And what will be the new area? That is 121. So initially it was 100, now it is 121. So difference is 21. Okay. And since base is 100, directly we'll be getting the answer in percentage. So it's 21% increase since it is an increase. Okay. So it becomes very simple if you start with the base 10. Okay. Now suppose in other case, suppose I increase the length by 10% and increase the breadth by 20%. Then what would happen? Initially the area is 10 into 10, 100. Now I'm increasing the length by 10%. Then the new length will be 11. The new breadth will be 12 if I'm increasing the breadth by 20%. So it will be 12. Now what 11 into 12? It's 132. So what's there? It is 32% increase in the area. Isn't it very simple? It's really a fun and it's really easy if you know this logic. Okay. Now suppose I increase one of the quantity and decrease the other quantity. Now the area is 10 into 10, 100. Suppose I increase one of the quantity by 10%. I'm making it to 11 and I'm decreasing the other quantity by say 20%. So it's 8. Now what is that? 11 into 8, 88. Now initially the area was 100. Now it is 88. That means there is a 12% downfall. Okay. Isn't it very simple? So you can play with the variables accordingly. Okay. Now suppose the area is 100. I'm increasing one quantity by 10% and I'm decreasing the other quantity by 10%. So it's 99. It's 1% decrease. Okay. So friends, if both the percentage is same, that is increase percent and decrease percent is same, that is x, then in all there will be a x square by 100% decrease in the net value. As in this case here 10% increase and 10% decrease, that is 10 square by 100% decrease, that is 100 by 100, 1% decrease. So you can directly put this logic. Okay. Now in case of rectangle, whatever is increment or decrement in the variables, you can easily find out the percentage change in area, isn't it? Now let's do the problems which are given over here. Let's take them one by one. Now friends, let's see the first case. What will be the change in area of a rectangle if its length is increased by 25% and breadth is decreased by 25%? So same percentage increase and same percentage decrease. That means overall there will be an x square by 100% decrease. That is 25 square by 100% decrease. What is 25 square? That is 625 by 100 is 6.25. So overall there will be a 6.25% downfall in the area if length is increased by 25% and breadth is decreased by 25%. Okay, I hope you are clear. Now let's take the next one. Now length is increased by 15% and there is no change in breadth. That means only one variable is making impact. There is no contribution of the other variable. That means the area will also be changed by 15%. No calculations are required. Okay, I hope you are clear. Now if length is decreased by 10% and breadth is increased by 20%. Let's take 10 into 10, 100. Length is decreased by 10%. That means the new length is 9. Breadth is increased by 20%. That is the new breadth is 12. So 12 into 9 is 108. So overall there is 8% increase. Okay, isn't it very simple? Now both of them are decreased by 25%. It's 100 Now 7.5 into 7.5. What is the square of 75? It is 5625. So it is 56.25. Now what is the net decrease? You deduct 56.25 from 100, then it will be 43.75% downfall, isn't it? Now suppose both of them are increased by 5%. Let's begin. 10 into 10 is equal to 100. It's 10.5 into 10.5. What is the square of 105? We have learned this in our calculation sessions. Plus 5 plus 5. It's 25 and 110. Okay, cross addition. So it's 110.25. That means actually what is the increment? It is 10.25% increment in the area if both the quantities are increased by 5%. I hope you are getting the method. Now let's take the case of a circle. What will be the percentage change in circumference if radius is doubled of a circle? And what is the formula for circumference of a circle? C is equal to 2 pi r. Now friends, there is only one variable in this case. Okay, so circumference is totally dependent upon the radius of the circle since 2 pi is constant. Okay, now we just do not consider 2 pi in our calculations since the circumference is dependent upon radius. Okay, now initially suppose radius is 10, then circumference will be circumference is dependent upon r. Initially if radius is 10, circumference will be 10. Okay, now if there is any change in radius, in this case the radius is getting doubled. Okay, so it's 20, then circumference will also be 20, that is double. Okay, that means from 10 to 20 it is 100% increase. Okay, so what will be percentage change in circumference? In this case it will be 100% increase. I hope you are getting my point. Now in this case let's discuss. Friends, in case of area is dependent upon the square of radius, that is area is pi r square. Here pi is constant, will not be considering it, will begin with radius only. Now initially the radius is 10. Okay, so area will be 100. Okay, friends, in this calculation we are not considering pi, so just be very careful about it. So area is 100. Okay, now if radius is halved, that means the new radius is 5, the new radius is 5, so the new area is 25. So what is the downfall? That is 75, and this downfall is from 100, so directly it is 75% downfall in the area. Okay, now suppose radius is tripled. Let's see over here, 10 into 10, 100. If radius is triple, that means it's 30 into 30, that means 900. So there is an 800% increase in the area. Okay, friends, various questions are asked in this on this concept. See, what is the new radius, that is also asked, or how many times the new radius will be of the original radius how many times the new area will be of the original area. So the new area will be 9 times the original area, and there is an 800% increment in the area. So you should be clear about both the concepts, that how many times the area is increasing and how much is the area increasing. Okay, I hope you are clear. Now in this case the radius is increased by 25%. So let's take, it's 10 into 10, 100, and 25% increment means 12.5 into 12.5. Now what is the square of 125? It is 15625. Okay, so what's the net increase? It's 56.25% net increase in the area if radius is increased by 25%. Okay, I hope you are clear with the concept. Let's take the new case. Now this is a case of volume of a sphere. Now what is the volume of sphere? Volume is 4 upon 3 pi r cube. That means volume is only dependent upon radius of the sphere, since 4 upon 3 pi is a constant. Okay. Now we see the power as 3. Okay. So further we begin with the basic radius as 10 and will not be taking into consideration this constant. Okay. So let's say initial radius is 10. So 10 into 10, 3 times, it is volume. Okay, so it's 1000. It's volume and its radius. Okay. Now if radius is tripled, that means it is 30 into 30 into 30. So the new volume is 3 3s are 9, 3s are 27,000. Okay. Now what is the increase? That is from 1000 to 27,000, it is 26,000. It is the increment on 1000. That is 26,000 is increased on 1000. That means on 100 it will be 2600. Okay. So the percentage increase in this case is 2600%. Okay, I hope you are getting my point, since we are getting the difference from 1000 over here, but for percentage calculation we should see the difference from 100. So from 1000 the increment is 26,000, that means from 100 it will be 2600. Okay, so if the radius is tripled, the percentage change in volume is 2600%, and that will be increment. Okay. Now if you are asked how many times the new volume will be, then in that case the new volume will be 27 times. Okay, since it is 1000 and it is 27,000, that means the new volume will be 27 times. So both the questions are different. You should be very careful while answering this sort of questions. Okay. Now in this case the radius is decreased by 20%. Now let's take radius and volume. 10 into 10 into 10, and the volume is 1000. Now radius is decreased by 20%. That means the new radius is 8 into 8 into 8. It's 512. That is 8 cube. Now what is the difference? It is 488. Okay. Definitely there is a downfall. On 1000 the downfall is 488. That means on 100 the downfall will be 48.8. That means on 100 the downfall is 48.8. That means the overall downfall is 48.8%. Isn't it very simple? You're just getting the difference from 1000 and converting it to 100. Okay, just reducing a 0. Definitely the problems become very simple if we take the initial value of the variable as 10. Now let's see. If radius is increased by 20%, now 10 into 10 into 10 is 1000. Now radius is increased by 20%, that is 12 into 12 into 12, that is 1728. Now what is increased? That is 728. This increment is on 1000. So on 100 the increase will be 72.8, and that to be in percentage. Okay, so if radius is increased by 20%, the volume of the sphere will be increased by 72.8%. Okay, friends, be careful. Here we are getting the difference from 1000. So to find the difference from 100, we need to divide it by 10. Okay, I hope you are clear. Now in this case we have to see the volume of a cylinder and its percentage changes if we play on radius and height. Okay, now what is the formula for volume of a cylinder? That is V is equal to pi r square h. Here there are two variables, radius and height. Now radius is coming for 2 times and height is coming for 1 time. That means height is a linear function and radius is a square function in this case. Okay, now let's begin. Initially we'll be having the value of radius as 10 and value of height as 10, and definitely pi is constant over here, so we are not going to consider it. So initially the volume is RRH is the volume. So it's 10 into 10 into 10 is equal to 1000. Okay. Now let's take the first case. If radius is halved, that means the new radius is 5 and height is doubled. That means the new height is 20. Okay. So what will be getting? 5 5s are 25, 2s are 50. So it's 500. So what is the net change is 500. Now this 500 is the change from 1000. So from 100 it will be 50. Okay. And definitely it's a downfall. So if radius is halved and height is doubled, overall there will be a 50% downfall in the volume. Okay, I hope you are getting my point. Now let's see the next one. Radius is increased by 10% and height is decreased by 20%. Radius is increased by 10%, then the new radius will be 11 and height is decreased by 20%. That means the new height is 8. Now we have to multiply 11 into 88. So it's 8 and 8. 8 and 8, 16. I put 6 over here and the 1 will be carried forward. So it's 968. Okay, so what is the difference? It is 32 and it's a downfall. Okay, now this 32 is a difference from 1000. So from 100 it will be 3.2. So it is 3.2% downfall. If radius is increased by 10% and height is decreased by 20%, there is a downfall of 3.2% in the volume. I hope you are getting my point. Now see the next case. If height is decreased by 37.5%. Since I have already told you height is a linear function over here, so as much increase and decrease percentage in height is there, the same change in volume will be there. Okay, so no need to calculate. If height is decreased by 37.5% and there is no change in radius, then even the volume will be decreased by the same percentage, since height is a linear function over here. Okay, so it's 37.5% decrease. No need to calculate. Now in this case, if radius is increased by 15% and there is no change in volume. So further, since radius is a square function, so the initial volume is based on 100 and the new one is, that is 15% increase, it's 11.5 into 11.5. Just calculate it. That is 115 square. So what is the net increase? 32.25. Since we are getting the difference from 100, so the percentage difference will also be 32.25%. Okay, I hope you are getting my point. Friends, must be keeping in mind that radius is a square function, so it will work like this as in this example, and height is a linear function, so the percentage change in height and the corresponding percentage change in volume will be like this as in this case. Okay, I hope you are getting my point. Now let's see the case of a cuboid. Friends, what is the volume of a cuboid? Volume of a cuboid is length into breadth into height. There are three variables on which this volume is dependent. Okay, friends, if there is change in any one of them, that is if only length is changing, then it is the volume will be directly changed corresponding to the change of length. Okay, if suppose let me take one example. If breadth and height are constant, if length is increasing by 10%, then the volume will also be increasing by 10%. If similarly in the case, if only breadth is increasing or decreasing by X%, then the volume will also be increasing or decreasing by X%. Okay, so we should be clear, either the increment or decrement is a linear, quadratic or cubic. That means only one function is changing, two functions are changing, or three functions are changing. Okay, so in the given case, height and length and breadth, all the three functions are changing. So let's assume the initial values is 10, 10 and 10. So length into breadth into height is volume. Okay, Now height is triple, that means height is 30. Length and breadth are halved, that means it is 5 into 5. So it is 750. Downfall of 250 is there. This downfall is from 1000. So from 100, it will be 25. Okay, so it's a 25% downfall in the volume if height is tripled and length and breadth are halved. Okay, now suppose there is no change in height and length and breadth, both of them are increasing by 10%. So in that case, volume is equal to length into breadth into height, which is 10 into 10 into 10. Okay, and suppose change in length is 10%, so the new length is 11. Change in breadth is maybe an increment of say 12%, so I'm sorry, 20%, so the new breadth is 12, and we are not considering this. Okay, so the net change is from 100 only, so it's 100 and it is 132. Okay, so the net change is 32% up. Okay, so just be very careful in seeing with how many variables are getting affected. Okay, friends, if you know all these logics, then definitely the percentage mensuration problems will be a fun for you, very easy for you. You can solve this sort of problems very easily in your examination times. Okay, I hope you might have learned a lot in this particular session. In the next session, we'll be taking some more applications of percentage. Okay, by that time, do revise this session and the previous two sessions also. Bye bye.